Okay, we're back. So I'm closer to North Dakota now. Okay, lesson 4.7, we're still in working with point slope form. And I told you we'd be back to this today and doing some more with it. So here's what's going to happen today. Today we're going to be given information that helps us be able to write an equation in point slope form. And then we're going to use point slope form to help us write it in slope intercept form. So we're not going to stop with it at point slope form today. We do have to take it a step further and write it in slope intercept form. Okay? It says it right here. So we're going to start with point slope form and take it to slope intercept form. So we have a line that has a slope of negative 1/3. The ordered pair negative 3, 8 is on the line. We know how to write an equation for this in point slope form. So we'll start there. We have our y sub 1 value right there, so y, take away our 8. We have our m value right here, so we have negative 1/3 times in parentheses, here's our x sub 1 value, so we have x, take away a negative 3. Let's clean that up. And we have y, subtract 8. And we have negative 1/3 times in parentheses, instead of x minus a negative 3, it becomes addition, and the opposite of negative 3 is positive 3. So there's our point slope form cleaned up, but again, we want slope intercept form. So what we have to do now is we have to do the simplifying over on this side. We have to do our distributive property. So we'll leave the left side as it is. We won't mess with that yet. We'll take our negative 1/3 times the x, bring along the addition sign between that x and 3, and take negative 1/3 times 3. So negative 1/3 times 3. We can put 3 into a fraction by putting it over 1. What's a negative times a positive? Negative, and basically we're taking 1/3 of 3, or we're saying we have 1, don't we? So I'm negative 1. Now we need to get the y alone. So we're going to get that, subtract 8 out of there by adding 8 to both sides. And we now have our y alone. We have y equals negative 1/3 x. We have a negative 1 plus 8. That would be plus 7. The one and only slope intercept form name that there is, because it can only have one, a line can only have one slope, a line can only have one y-intercept. So we know this one would cross the y-axis at positive 7, and we know that it would be falling because it has a negative slope, and it wouldn't be very steep. Okay, well now we have two ordered pairs, but we do not have a slope. So I guess we're going to have to start with finding the slope, and then after we find the slope, then we'll pick which point we want to use to help us write point slope form, and then we'll take it from point slope form to slope intercept form. So m equals, let's start with this one, 5, the first ordered pair. Take away the other y value, negative 1. Take away the other x value. So we have 5 plus the opposite of negative 5 is 5. And we have negative 1 plus the opposite of negative 3 is 3. So upstairs we end up with a positive 10. Downstairs we end up with a positive 2. We now know that the slope of our line should turn out to be 5. So this is our m value right here. Okay? So we have a slope of 5. So now let's decide with m equal to 5 and one of our ordered pairs. I'm going to guess maybe you want to work with negative 1, 5 because it only has one negative in it at least. Okay? So we'll work with that slope and that ordered pair, and now we'll put it into point slope form. So we have our y value, y minus 5. We have our slope of 5, x, take away our x sub 1 value, which is negative 1. So it looks like we should probably do some cleaning up again here. Y minus 5 equals 5 times x plus negative 1 becomes positive 1. Now we can do our simplifying first. We're always going to have to do that distributive property there. So y, take away 5. 5 times x, 5x. Bring our addition sign down. 5 times 1, 5. And lastly, we will add that 5 to both sides to get it out. It's y minus 5, so we want to get rid of that. So we're going to add 5 to both sides. And we have the equation of this line in its slope-intercept form name. Now, if we had used the other ordered pair, if anybody worked ahead or decided to, just go against what we were doing, if you used ordered pair negative 3, negative 5 instead, in the end, you better have the same equation we do. Y equals 5x plus 10. Because any point on that line with our slope of 5 would create this one and only slope-intercept form name. Okay, well now this time they give us an x-intercept and a y-intercept. How are we going to write an equation in point-slope form, first of all, given that these are the intercepts, but we don't know anything else? Well, here's what we do know. We know that when we have the x-intercept, it is ordered pair negative 2, 0. And we know that when we have the y-intercept, it is ordered pair 0, 3. So we were just given, in a roundabout way, 2 ordered pairs, just like we just had in number 2. So first on our agenda is find the slope of the line. So we're going to do m equals, let's start with the 3 in the second point upstairs here. 3, take away the other y value of 0. 0, take away the other x value of negative 2. So we end up with 3 take away 0 upstairs, and we really have 0 plus 2 downstairs. So what do we have? We have a slope of 3 halves. Here's our slope. Now, in this particular situation, do we really have to put it in point slope form first to get it to slope intercept form? We already know B. We already know it. Here it is, right here. So we are actually going to go straight to writing the equation in slope-intercept form. We have y equals 3 halves our slope, x, plus our y-intercept of 3. There's the equation for this line. So again, could have written it in taken one of those points and written it in point slope form, and then did our simplifying and getting y alone. We should have gotten the same thing. So we're shortcutting it because why do all that when we already know the y-intercept? Okay, so you have to just kind of like evaluate with the information that's been given to you. What can I do? What do I have? What do I need to find? Okay, we're going to do a application problem on the back, and you need your books open right now to page 280. So get your books open to page 280 and zero in on problem number 35. So while you're maybe opening, finding that page, I'll start reading the problem to us. At higher altitudes, water boils at lower temperatures. So in other words, the higher you go, the lower the boiling point. This relationship between altitude and boiling point is linear. At an altitude of 1,000 feet, water boils at 210 degrees Fahrenheit. At an altitude of 3,000 feet, water boils at 206 degrees Fahrenheit. Write an equation in slope-intercept form that represents this linear function. Then find the boiling point at 6,000 feet. So what's in control here, the independent variable? I would say that it's probably the altitude. How high up are you? So we're going to make the independent variable the altitude, and the altitude is measured in feet. And the dependent variable is the boiling point. What does water, what do things boil at? And that's measured in degrees Fahrenheit. So basically, we have degrees Fahrenheit per foot when we find slope. Okay, the y's are upstairs, the x's are down. Now, they gave us some information that we can actually set up ordered pairs with the altitude, the number of feet being our x value, and the boiling point being our y value. So we have ordered pair at 1,000 feet, water boils at 210 degrees Fahrenheit. So ordered pair 1,000, 210. We also have been told that at 3,000 feet, water boils at 206 degrees. So first thing we need is a slope. We have two ordered pairs, we should be able to find slope. So let's start with the first point. 210, take away the 206, the change in the altitude over the change, we got to come back and grab the 1,000 and take away the 3,000, the change in the altitude. Well, upstairs, the change in the degrees Fahrenheit is 4. The change in the altitude is a negative 2,000. Well, we're not going to divide this out into a decimal. We're actually going to just simplify it as a fraction. So first of all, what is a positive divided by a negative? We get a negative, and 4 goes into itself, and it goes into 2,000, so it goes into itself once. How many 4s in 2,000? Well, there's 5 4s in 20, and then we have those other 2 zeros. So negative 1/500th is the slope. So what is this telling us, really? That for every positive increase of altitude of 500 feet, the boiling temperature, their boiling point is going down 1 degree Fahrenheit. Or you could think of it this way. The boiling point is going up 1 degree Fahrenheit for every decrease going down 500 feet in altitude. Okay, now we have our slope, so now we should be able to use our slope and one of our ordered pairs because neither of these points are the y-intercept. How do we know that? We don't have an x value of 0. So we have to find now, so using the fact that we know that slope is negative 1/500th, and one of those ordered pairs. How about the first one? It's got smaller numbers. 1,210. Okay? So let's write our equation in point slope form now. We will have y, subtract our 210, equal to a negative 1/500th times x minus our x value of 1,000. Okay, let's get that simplified and get the y alone. So we have, So this over here is going to stay y subtract 210. Our slope right now is going to remain negative 1 over 500. And it's going to be, sorry, we're doing distributive property here. So that negative 1, 500 is going to get multiplied times both of those terms. Now, we should change this to add the opposite so that we multiply properly. So bring down the addition, and now we have a negative 1 500th times a negative 1,000. So a negative times a negative is a positive, so that kind of makes both of those guys positive. 500 goes into itself once, goes into 1,000 twice. So we have 1 times 2 upstairs, and those ones downstairs we can ignore, so we have plus 2. And now we're ready to move our 210 away from the y. We need to add it. We have y alone. We have negative 1 500th x plus 212. No cleaning up needed. We have our equation as asked in slope-intercept form. Now it says, then find the boiling point at 6,000 feet. So the boiling point at 6,000 feet, let's write that in our notes. Boiling point, 6,000 boiling point at 6,000 feet. So, okay, so let's assign some variables here to these guys. The boiling point, is that our x value or our y value? It's our y value. So we're going to be looking for y, it looks like, when x is 6,000. So we are really looking for ordered pair 6,000 y. We need to be able to fill in the blank there. What is the y value for that ordered pair? That would be on this line. So we'll take our equation, y equals negative 1 500th x plus 212. It's the x value we have to sub in. So we will sub our x value of 6,000 in. And come over here and let's do what is negative 1 over 500 times 6,000 over 1. First of all, a negative times a positive is a negative. And then we're going to answer the question, how many times does 500 go into each of these? So 500 goes in, I think we better do 100, how about? Let's try that first. 5 times. So 100 goes into 500 5 times. How many times does 100 go into 6,000? It goes in there 60 times. Now let's see how many times does 5 go into itself and into 60. So it's 2 times. 12 times, I mean. So we have 1s downstairs, we have a 1 times 12 upstairs, so this becomes a negative 12. And then we have our plus 212, our y-intercept. And so at 6,000 feet, the boiling temperature is whatever negative 12 plus 212 is. It's 200 degrees Fahrenheit. So we just found the y value for our x value of 6,000. So there we go. Okay, so today, being able to take it now from point slope form and writing it into slope intercept form, and hopefully with this, you did the homework yesterday, so you're better prepared for today and can get this accomplished. Good luck. See you after break.